Discuss the nature of seasons. Explain why the Northern Hemisphere experiences winter while the Southern Hemisphere experiences summer. Discuss the effect of air pressure on the human body. Why does air pressure have to be regulated in airplanes and submarines? Assignment Discovery now presents The Weather Machine.
Every hour of every day, somewhere in the world, it is raining. The hot, humid rainforests at the equator are balanced by the freezing ice caps near the poles. Snow melts from the mountaintops, while the dusty plains suffer from drought. Temperature, air pressure, wind, and moisture are the conditions that create our planet's weather. A sunny morning, a snowy day, or a stormy night. Weather is simply the condition of the air around us. The atmosphere was created approximately 4.5 billion years ago, when enormous reservoirs of water and gases erupted from beneath Earth's surface. The atmosphere is our shield that traps the sun's heat to protect us from the deadly cold of space. But it is surprisingly thin. All the world's weather occurs in a thin layer of air just 8 miles high, called the troposphere. Every extreme is found here, from steaming hot to freezing cold, from powerful winds to torrential rainstorms. Difference in temperature is the weather change we notice most easily. Temperature is simply the measure of cold or hot on a particular scale. Fahrenheit is the common scale for the United States, but all other countries use the Celsius scale. All of our weather is driven by the sun, whose center burns at an incredible 27 million degrees Fahrenheit. This sunlight must travel about 93 million miles to reach Earth, but it only takes 8 minutes and 20 seconds to arrive. The sun's heat warms some parts of the Earth more than others. At the North and South poles, the sun's rays strike at a low angle. Less radiant energy reaches this part of the globe, so there are freezing temperatures all year round. Antarctica is the coldest continent of all. On this freezing tundra is where the lowest temperature on Earth was recorded. In July 1983, Vostok Station, in the middle of the continent, reached a minus 128.6 degrees Fahrenheit. The Earth's temperature depends on its position in relation to the sun. As the Earth turns on its axis, one hemisphere is tilted toward the sun and receives direct rays. The other hemisphere is tilted away and receives less sunlight. It is winter. But 6 months later, this hemisphere is tilted toward the sun and has its summer. Without this simple tilt, our climate would be the same all year round. Almost all of the world's deserts are found 30 degrees north and south of the equator. The Gobi Desert in Asia, the Mojave in North America, and the Great Australian Desert are hot, barren regions that receive little rainfall. The Sahara Desert in Africa is the largest of the world's deserts, roughly the size of the United States. In September 1922, Al Azizia, Libya, reached a scorching 136.4 degrees Fahrenheit, the highest recorded temperature in the world. Temperature not only affects how hot or cold we feel, but it changes the air pressure. That's the force of the atmosphere pushing on the Earth. Warm air weighs less than cool air, and creates a low-pressure area. Cool air is heavier and creates an area of high pressure. Seen from space, these clouds mark the path of a jet stream, a narrow band of fast-moving air, about 8 miles above the Earth. Jet streams are among the most powerful forces on our planet. The polar jet stream influences weather across the northern hemisphere. Airplanes try to keep out of its path when traveling west, but they do their best to ride with the jet stream to speed their journey east. The jet stream breeds storms beneath it wherever it goes. When it curves north, the jet stream suddenly goes faster and pulls up air from the ocean surface. New air rushes in to replace rising air, and at sea level, this creates huge gusts of wind. This is the start of a region of low pressure, or a surge of warm air. The jet stream is like a river. When it is strong, it flows fast and straight. But when the jet stream is weak, it meanders. This wandering course can cause cold air to sweep down from the Arctic and ridges of warm air to move up from the tropics. The jet stream can create hot weather in Moscow, freezing temperatures in Rome, and warm weather again as far north as Iceland. The jet stream can also create a blocking area of high pressure, a flow of cold air. Wind is the movement of air from a high-pressure area to a low-pressure area. The rotation of the Earth prevents winds from the poles and the equator from blowing directly north or south. Instead, the winds that blow toward the equator curve west, and the winds that blow away from the equator move toward the east. This is called the Coriolis effect, and these winds are called trade winds. Trade winds complete the two giant loops of air that circle the Earth. These enormous loops of air are called Hadley cells, for George Hadley, an 18th century British lawyer who first tried to describe them. A cell is a mass of air that moves together in a circular motion. The North and South poles each have a cell of their own. Cold air sinks at the poles and then flows north or south, where it warms and rises again to complete what is called a polar cell. In the middle of each hemisphere, squeezed between the tropical heat of the Hadley cells and the chilling cold of the polar cells, is the temperate zone. If you look closely, you can see a battle going on in the temperate zone, a clash between warm and cool air. This clash is known as a front. The name has its roots in World War I, when weather information became a classified secret. The neutral Norwegians formed their own forecasting service and set up a string of weather stations along the Norwegian coast. They soon discovered that the warm air blowing over the country from the North Atlantic was a single mass that arrived all at once, like a huge army marching forward. They called the line where this warm air arrived a front, because it resembled the battlefronts of the war in Europe. Today's meteorologists, including those on TV, still plot these military-looking fronts on their weather maps. They are an essential tool in predicting where it will rain. But before there can be rain, there must be moisture. As air flows over the world's oceans, it absorbs water vapor. When the air holds as much moisture as it can, it becomes saturated. The temperature at which the air becomes saturated is called the dew point. If the temperature falls below the dew point, the moisture condenses and falls to the earth as rain, sleet, or snow. These vast interconnected forces are why every day is unique. The freezing icicles in the Arctic are balanced by a steamy rainforest near the equator. These wonders of weather bring diversity to our days, but they also remain a mystery, an ever-changing puzzle that can never quite be solved.